Hello and welcome to the Analytics Show, the podcast of business through the lens of data science. But together, we'll dive into learning and sharing where various industries are heading and how data and analytics is at the heart of shaping business growth and productivity. Let's spark different ways of thinking about data and analytics that is relevant to you and prepare your business for future disruption. I'm your host, Jason Tan. I'm delighted you could make it on this journey with us. Hey guys, to continue to get support tips, techniques, and tools and learn from the expert, hit that subscribe button wherever you are so we can keep in touch and continue our lifelong learning together. So, are you using your company data to its full potential? Take our embedded analytic assessment to find out your score. A leading organization like Facebook, Apple, Amazon, Netflix, and Google have moved beyond dashboard and embedded data science directly into their daily business operation. With our 3-minute test, you will discover your potential in optimizing customer experience and revenue through embedded analytics. You will gain greater clarity, insight, and advice to embed analytics. Plus, you will receive customized results instantly. Find the link to this assessment in the description of this episode. Hello, Mark. Thank you so much for joining us to present at the Queensland Advanced Analytics. I'm so excited to have you here presenting. So just a little bit of the background about the meetup. Can everyone see my screen? So yeah, this is Queensland Advanced Analytics, where we come here to talk about data and advanced analytics for the people based in Brisbane. Although I know that we actually traditionally have been getting people all over the world joining. Now, the meetup event is sponsored by the Data-Driven Analytics, which is a company that I run to help people embed analytics into the daily business operation. If you guys are not joining the meetup or not attending the meetup, feel free to jump in my Analytics Show podcast, where I interview business leaders around the world, how they do analytics to run a high-performance organization. Now, enough about me. I am excited to hear what Mark is going to share with us. I am going to make you as the co-host so that you can share the screen. Without further ado, please take it away and share some of the exciting things that you do.
Yeah, hi everyone. Thanks, Jason, for having us. It's a real privilege, and I appreciate the opportunity to present to everyone. And first, I guess maybe a disclaimer. I do work for AWS. I have worked for AWS for about a year. The views in this presentation I will take ownership for. I think they fairly accurately reflect the position of AWS on a lot of this thinking anyway, but that's a separate spaceship from the spaceship that we're on today. So I didn't even have that in my script, but I just thought I'd better say it. Just to be on the safe side. So yeah, the opinions today are my own, and they're based on 20 years, maybe longer. Goodness me, look at this grey hair. That was partly from having 4 kids, but partly from working in the industry for 20 years as well. We'll tell some of those stories today. Now I better share my screen just so you got something better to look at than my grey hair.
You do have a really good look though, because it's all silver and all white, so I think it resembles George Clooney quite a bit.
Oh, brother, thank you. I'm flattered. That's very kind of you. The other one I get is Harrison Ford.
Yeah, that's true.
At one point, I had this spiky hair with gel and everything, and I looked exactly like the guy out of the movie Fugitive. Harrison Ford in that movie. Anyway, the doctor. Okay, screen share. Let's go.
Well, you do know what is your second career option if you decided no longer to get involved in data and analytics. So yeah.
Yeah, Sydney has a big enough industry. Okay, so hopefully we're looking at a screen called Building Data Products. Is that right?
That is correct.
Okay, excellent. And then let me just bring up what I need to look at here. So yeah, as I mentioned, opinions on my own, and let's dive in. So I guess it probably makes sense to position the conversation by thinking about where we've come in terms of analytics historically. And so there's been this journey, and it was actually pretty stable for a long time. So back in the days, I'm only talking 10, 7 years ago, when we were brought in for a consulting piece and we're going to do an information management strategy, we're going to map out a data warehouse strategy, and here's what you've got, and here's your target state, and here's how you want to get there. We used to say, like, all the lessons have been learned. Data warehousing is, very mature. It's been done for 20 years. Almost nothing's changed in 20 years. And it was true at that point in time. And then probably, depending on how far you go back, but this term big data came along, and it really was a transition, actually. It was really because storage got cheap enough that we could keep data that we never used to keep. And I think it was probably the gentleman who was the CEO at EMC coined the term big data. Gartner actually came out with this whole marketing pitch around what they called extreme data. And this was back in the days when everything was extreme, extreme sports, people jumping out of airplanes with surfboards and parachutes, and everything was extreme this, extreme that. And Gartner came out with extreme data. And what they were really talking about was high volume, high velocity, multi-structured, so structured, semi-structured, unstructured, data coming off sensors, IoT, all that kind of stuff. And it used to be the case that it was just too expensive, chuck it out, can't use it, or we can keep, a week's worth of data or a month's worth of data, and then it gets archived on tape. And that began to change because storage became quite cheap. And so what we've seen there is the emergence of a new model, the data lake. And I'll get into what the difference is really between the data warehouse and the data lake. Probably worth talking about that now because it's quite pivotal to understand that. So traditional data warehouse, and this was the only way we knew how to do it for 15, 20 years, was highly structured data, but also highly regulated, highly modeled, highly controlled. And the classic approach was, I remember doing this with one of the utilities based in Sydney, was you'd have an enterprise architect would come in and map out all the business processes across the organization and reduce them down to actors and processes, and then that would reduce down into like a conceptual data model. And that took 18 months of consulting right there in the organization that I'm thinking of. And you end up with this big document that's a conceptual data model. And then you model that into a logical data model, and then you model that into a physical data model. And then you bring all your source systems through a complex ETL data transformation process into this data model. And then the theory is this data model can now answer any question about the business that you want to hit it with, because it's got all the data coming in and it's all been abstracted away from whatever process or system. Doesn't matter whether it was in Salesforce or whether it was in some custom database or some custom application. It all came into this wonderful enterprise data model, and any business question could be answered out of that data model. And it was big bang, and it was expensive. I remember there was one bank in Singapore that spent, so this data model here in the middle, they used to be really complex, and they were so complex that a whole lot of people made a whole lot of money out of developing them for a specific industry like financial services or telco. When I ran the data warehouse at one of the telcos in Australia, we bought a data model from a company called Teradata, and it was called the Communications Logical Data Model. And all it was the data model they built for some telco in America, and then took all the money that they got paid to build it, and then took what they built and then sold it to everybody else because they were another telco. And this bank in Singapore did the same thing. They bought the IBM Financial Services Logical Data Model, and then they put it in their data warehouse. That was $2 million. And then they spent 3 years and $15 million bringing all their source systems into that data warehouse. And then they had this incredible data model that could answer every business question that was being asked by a bank in America 3 years ago. So we had some problems with the data warehouse model. But the biggest problem was the ability to make changes to that, because this data model was so finely tuned. If you wanted to bring in a new data source, or you had a new product that was being launched in one of these systems and the data model didn't know how to cater for that, you had to engineer that into the data model. And then you had to look at the impact analysis on everything downstream and look at what else was being affected by that. And that was that, you know, we used to have a joke, honestly, when I was the data warehouse manager. It was the answer to every business question is 6 months and $500,000, because that's how long it's going to take to run a project in the data warehouse. And that's how much it's going to cost you to bring in the systems and do the impact analysis to answer that business question. And so over time, it became unsustainable because businesses began to evolve much, much faster. You know, there was a time when if a bank wanted to bring a new product to the market, it would be a 2-3 year roadmap to, you know, figure out what the product was going to look like, how they would market it, who the target audience was, but then to do 12 months worth of work in their IT systems, being able to cater for that new product. Now you've got IT teams that are literally rolling out multiple production releases in a single day with, you know, CDCI, pipelines, agile. So IT can keep up with the business. It probably takes the marketing team longer to figure out how to bring the product to market than it takes the IT team to figure out how to shoehorn it into their existing processes. But the data warehouse can't keep up with that. And so we saw the emergence of a different process, partly because of the big data and partly because of the pace of business change and the data warehouse not being able to keep up with it. And it was this thing called the data lake. And so that was one of two, what I would say are the tectonic changes that have happened, or the tectonic shifts that have happened in the last 5 or 10 years in the space of data and analytics and data warehousing. And it's all moving towards the subject that we're talking about today, which is data as a product. So let me bring that up as well. So the first big shift was actually the decentralization of the data model, if you like. So a data lake tackles this problem that the data warehouse has by saying, give me some data from any one of these systems and I'll put it in a repository where people can come and do analytics on it, just like that. And so the business may be sitting over here saying, I've got to do some analytics. I know it's in a system over there. It's not in my data warehouse. I need to access that data. IT, can you help me? And IT goes and looks at it and goes, yep, well, that's this kind of data and it's this kind of constraint, and we can bring that in using this pattern. You'll have access to the data in 48 hours or whatever the SLA is, because they're not doing that complex transformation into this data model. They're taking data that's reasonably raw and bringing it into an analytics platform that we call a data lake, and then giving the business access to that. Now, there's a few controls that you have to put around that, because otherwise you end up with a mess. And that's why, you know, some data lakes became data swamps, because everybody just threw everything in there and everybody accessed it and half the time didn't understand what they were accessing. So there's a few controls that you need to put around that data lake in order for people to come and do or be able to use the data safely. And so I'll talk about that when we go into this model, because those safety rails and the management of that access to the raw data is fundamental to the success of data democratization, and it's fundamental to the evolution of data products. It's a critical factor in that value pipeline. But you've got to start with IT being able to say, it won't take 6 months, it won't take 3 months. I can give you access to that data in 24, 48 hours, 1 week, whatever, subject to these caveats. We haven't done any data quality control. You need to find a business SME who can tell you how to use it, etc., and then capture that knowledge and expose it in a safe way. So I'm sort of preluding to some of the content that we're going to cover later in the presentation, but that's kind of where things are up to. I might just pause because I've been doing a lot of very fast talking and see if there's any questions on the story so far.
Not from me, Mark. Following along makes sense so far.
I agree, and I can relate to a lot of what you were saying, especially the part of the rigid data model at the data warehouse that is taking forever to respond to the business.
Yeah, yeah. And as an IT professional in that role, you get incredibly frustrated because it's like, I know what the business wants. I know we can do it. I just can't do it quickly and I can't do it cheaply. Lisa, you came off mute for a second. I wondered if you were going to ask something or say something.
No, I was just going to say, no, I have no questions. That's what I was going to say. No, it's very interesting. So thank you.
Cool. Yeah, no problem.
Mark,
So I
sorry,
guess-
Peter again. Just, I guess
Yeah.
maybe a question. What's your view on business maturity, I suppose? So trusting people with that data lake concept kind of does assume that there is a reasonable level of maturity already that can use it, whereas having that more traditional data warehouse model is, I suppose, a little more trustworthy if your business doesn't quite have that same level of maturity to do it themselves. I'm just wondering if you have a view or if you've got experience around managing those organizations that don't quite have that maturity to just say, yes, go and do your thing in data lake.
Yeah, definitely. I think there's probably two angles to that. One is the provision of knowledge around the data sets that anybody is able to access. So what I would call business metadata, or a data dictionary, a data catalog. So this is the data set that came from, what's a good example? One I was working with the University of Newcastle. Here's a data set of the readings from weather stations, temperature, humidity, and rainfall across the Hunter Valley wine growing region at these particular stations. And so you've got a lat long, you've got various readings, blah, blah, blah. These are the caveats. Not every day or not every hour did we collect information. Some of the sites provide a daily reading, whereas some of the sites provide 4 times a day. Some of the sites provide 24 times a day. Bang, 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 bang. So all of the caveats around how to interpret that data, that's business metadata, what I call business metadata, the classic contents that would go into a data catalog or a data dictionary. So for the person who wants to access that data, you would want to provide a process that ensured that they were up to speed on that knowledge, so that they have the safety rails to be able to use it effectively. And a simple example would be in the example I provided, some stations do not collect a reading on a given day. In other words, there's data missing. Therefore, if you're going to do an average of the rainfall between day X and day Y, you can't just do a calculation of the date Y minus the date X gives me 90 days of rainfall, and then take the total rainfall and divide by 90, because 15 of those days may have no readings whatsoever. So it has to be averaged over the actual number of days for which I have readings, rather than simply a date diff calculation. So that kind of metadata needs to be captured and exposed to the people who are going to access the data for whatever purpose they want to use it for. And then the second component is, kind of data literacy on the other side. And so I guess you're always going to have varying degrees of that, and people at varying levels of maturity in their data literacy and their analytics journey. But generally, you're going to have a subject matter expert who is passionate about the data, wants to understand it, has a little bit of nous around curating it, or at least curating the knowledge of it. And they often become, what we'll talk about in a few minutes, they often become the product owner for that data set. So this data set that was the rainfall, temperature, air pressure, and humidity readings from the base stations around the Hunter Valley wine growing area, that now becomes a data product with a data owner, and then the data owner curates the knowledge of that data product and decides whether and how to expose that data to the customers or consumers who want to come and consume that data. Now, I've just given away 3 or 4 slides ahead, but it's probably a good time to throw that in there, because that gets us thinking about how this model actually works. But yeah, fantastic point, Peter, because we've always thought the business aren't ready and not capable of safely accessing and using, the raw data in a way that they're not going to just come to a wrong conclusion, or they're going to get lost, or they're going to put it in Excel and start doing crazy things. And often, even as the data warehouse manager at the telco going back 8 years, we had this fantastic data model, and half the time people would come and say, yeah, I don't trust that because I don't know what's happened to it. I want to go further upstream, and I want access to the raw data. And we go, oh no, you can't do it. You're not supposed to have that. And yet it was what they often wanted. in order to produce the outcome that they needed from data that they could actually interpret themselves, rather than having it interpreted through some data model that we purchased from an American company off the data model that they built for an American telco 5 years before, you know. So those are all components in that milieu, if you like. So we're at the point now, so that's the second big tectonic shift, I guess. The first one was that shift from the centralization of the data model to the decentralization of the data model in that data lake approach. And now we've got the decentralization of data governance. So, and that data management function, which used to be, you know, tightly constrained within the IT organization. We're only going to, you know, we're going to tick off every request for access to data and make sure that it complies with blah, blah, blah. And, you know, it's like, it reminds me of that yellow fish in the Finding Nemo movie with in the fish tank, and the bubbles pop open and the fish runs over and goes, "It's my bubbles, my bubbles, my bubbles." You know, we were like, my data, my data. And yeah, you had to go through flaming hoops in order to get access to it. So we're seeing that organizations that want to grow more rapidly and want to get value more rapidly from their data assets, they're moving away from that model towards a model of democratization and data products. So they're decentralizing the ownership and governance of the data. And it's also come along with this mind shift of, you know, data was an IT asset, IT owns the data, blah, blah, blah. It's actually never really been true. Data is, you know, a product of a business process, and there's a business owner of that business process, and the data produced is a business asset that sits in the business and can be more effectively governed and curated and managed as a business function than an IT function. IT can manage the infrastructure and all the cool stuff and look after backups and look after scaling and all the cool stuff they have to look after. But the data itself is a business asset and can be more effectively managed and managed in a more scalable way, because as the business grows, the expertise on this side grows. Whereas the traditional model, if the business grows, we've got to grow our IT team because we can't keep up with what they're asking for. So that's the two massive shifts that I think have occurred there: the decentralization of the data itself, and now the decentralization of the governance of the data. And so that brings us to our next slide. But before I do, it's probably another good point to just pause for some reflection, some feedback, throw in some ideas. Jason, Peter, Lisa, John, or Graham, who's just joined us. Welcome, Graham.
Nothing else from me yet, Mark.
Okay, sounds good. So then where we are is, these are the key challenges that we're trying to solve here with our data democratization and our data as a product. So we need to be able to scale access to the data from more teams and from more use cases, and have those supported without growing a massive team over here in IT, controlling everything and becoming effectively a bottleneck, which is what I always felt like I was as a data warehouse manager. We want to federate that data governance function across the business, because then as the business grows, automatically your data governance capacity grows, because you've got more people working with data and they become part of that data governance function sitting in the business rather than sitting in IT. We want that fast and easy access to curated data sets, although they could be relatively raw. That first stage of landing from a source system into the data lake, you would do some data validation there, maybe some basic data enrichment. So there was an example the other day actually where a customer was bringing in location information that had a lat long and an address, but some records had a lat long and no address. So their little validation process would do a quick API call to say, here's a lat long, give me the address, and then it would enrich that data before it landed it in that very first stage of what I'm calling raw data in the data lake, so slightly curated data. But that building that process, we don't want that to take 3 months. We want that to take, whatever the SLA is that IT can agree to, 24, 48 hours a week, maybe even same day in some cases, depending on how complex things are. So those are the problems that we're trying to solve. And how we are doing that is starting with that data lake concept. So a few points, I guess, about building a data lake. Now, I'll put another little disclaimer in here. In my diagrams, I've got what do we call it? Logos, icons that refer to AWS services like S3 here, for example. I've pulled this from a customer presentation. So it was a real life presentation to a customer, and we were pitching for Amazon services. But you can interchange those things. In fact, a data lake could be SQL Server. A data lake could be S3. A data lake could be a bunch of text files in a storage area. Sometimes the most elegant data lake is actually a relational database. If all you're bringing in is relational data, then don't take away that structure and drop it in CSV or JSON or Parquet or something funky just because you think it has to be a data lake. A data lake is not the technology. The data lake is the methodology by which you can land data quickly, curate it in a minimal way, but rapidly expose it to the business for them to come and start deriving value from it, and then building their data products on top of the data that you've brought in within your 24, 48-hour SLA. So just saying that the diagram is technology agnostic, even though there will be icons that reflect the fact that this was a presentation from Amazon to a customer. So data sources could be weblogs. They could be, we've got to cater for a number of different capabilities here. And those capabilities are actually what will determine the technology that you choose to use for your data lake. So if you're bringing in only structured data from structured sources, such as relational databases like Oracle backend to a web application or a customer-facing system or a mainframe potentially, or even a web app that has a relational backend, then you probably have your data lake sit in a relational database because it's just easy to move data from one to the other, and you retain the data types, you retain some of those controls around constraints within the data types themselves, for example, and you're going to keep that data quite clean as it was at the point of acquisition into the data lake. But we want to be able to, in some situations, you have to be able to cater for a much bigger variety. It could be data coming in by traditional batch with an ETL tool like Informatica. Amazon used a thing called Glue. It could be data that's coming in from a streaming source like Kinesis or Kafka or one of those streaming services. So if you're going to potentially have streaming data in the future, then you want to structure you want to have a technology as your data lake that supports that. Structured, semi-structured, unstructured. Semi-structured data could be Twitter feeds, could be XML, could be maybe there's a transaction that occurred at a bank branch or at an ATM, so that transaction has a location field, but there's another transaction that occurred on the web and it has no location. So some records come through with this many fields, some records come through with that many fields, semi-structured. Or unstructured data could be voice records from a call center. They could be voice to text. It could even be streaming video that you actually want to run analytics on. And there are more and more customers looking at ways to do that, whether for security or for maintenance of machinery. You've got a video feed showing what the machine is doing. And when the machine learning algorithm figures out that it's moving a few millimeters more than it should, sets off an alert. And then a mechanic comes down and services that device. Lots and lots of potential use cases there. But the point is that whatever your data lake is, needs to be able to handle, and also your ETL or your data acquisition technology. So if you know that at some point you're going to acquire streaming data, you need to have that pick list of technologies that say, if it's streaming, we're going to use Kafka. Fairly simple. So your target state architecture needs to take account of what that capability, what capabilities you need to be able to provide to the business. Then you've got to be able to have a schema applied to that for consumption. So again, as I mentioned, your data lake could be just a relational database. Your database could be something that lands that object store type thing, and then you provide like a metadata or a semantic layer over the top of that. In Amazon's case, it's the Glue catalog. And that allows query tools to come and query that data.
Hey all, I just want to give a quick shout out about this episode. It's sponsored by the Embedded Analytic Program at DDA. And the Embedded Analytic Program is designed for senior manager and executive in the business team who want to integrate data science into daily business operation and use it to drive customer experience excellence and revenue. And book unlimited strategy session for a full year and start embedding analytics into the business frontline. For more information about this program, please refer to the description of this episode. Now, let's get on back to the interview.
Let me see what else we've got here. Okay, so then we come to the point where the rubber really hits the road. So we've landed our data in the data lake. We've applied some controls to it so that number one, we've got our ETL or data acquisition pipeline. Number two, we've probably applied some basic data validation to take records that are incomplete, and either we reject them or we remediate them with a lookup to populate the missing fields, or we apply some kind of logic to populate the missing fields, or we just reject them completely, don't load them at all, or we put them in a queue for someone to come and look at and figure out what went wrong if it's important. So that process has all happened. And then we've put around that our knowledge of the data, the business metadata, the data dictionary that says this is data that has come from X and it can be used for these purposes, but don't use it for these purposes. And if you're going to do aggregation at this level, do this. And by the way, if you want the unsummarized data, you go to that data set over there, because this data set is summarized at the day level or by day, by user, by session, by whatever, So that data catalog becomes critically useful. While I'm mentioning data catalogs, I'll throw out the top three products that allow you to do that. One is called Alation, A-L-A-T-I-O-N. One is called Atacama, A-T-A-C-C-A-M-A. And the other one is Alation, Atacama, and I'll remember it shortly, but they're all out of the US. They're all reasonably mature startups. In the Magic Quadrants, Alation usually comes out on top. Calibra was the other one. But again, that depends on what you're looking for. But they give you that ability to crowdsource the knowledge of the data sets. And so, for every data set that is in your data catalog, you'll have a wiki-like page where people can say, here's what you can do, here's what you can't do. You'll have an owner of that page. You'll have people who are using that data making comments about the cool things they were able to do with it. You'll have people upvoting data sets that are really useful and downvoting data sets that are not so useful. There's an amazing plethora of capabilities built into those technologies that really support this democratization of data and the ability for users to scan the catalog. This is my business question. I think I need a data set like this. I type in a few keywords, I get some results. I see which ones people have upvoted. I look at the business questions that it was designed to answer. I form an opinion on whether I think that will answer my business question. And then I access that through my BI tool and I start doing some data exploration to see if it's fit for my purpose. That's the kind of life cycle that is now supported through this data democratization. So as part of that, we find the data product and the data product owner. So in the case of the university that I mentioned there, the process that I recommended for them, because they were starting from scratch effectively, and they had a backlog of people who were asking for access to certain types of data for certain use cases. And I said, okay, so here's your process. Business person, analyst, comes and requests, I want this data set, I want to do some analytics on it. By definition, now they become the owner of that data set or the future owner of the data product. Okay, because they put their hand up, they said they wanted, hopefully they've got some subject matter expertise in it. If not, it's their job to find someone who's going to become that data product owner. IT says, yep, got that data, we bring it in. Between IT and between the subject matter expert, they populate the data dictionary, they decide what the relevant quality checks and controls need to be. And then lo and behold, we've got our first data product, which might just be a table or maybe a star schema, but we've also got our first product owner. And that person who asked for the data will be exploring it because it's in its raw form, remember, and they'll be looking for ways to reason over it, to derive insights from it. And very quickly, they're going to start building second level, what I call second level data layer or second level data assets. So I started with raw data. As the subject matter expert or as the person with a business question to answer, I applied logic to that. I built an asset out of that, which could be a view, or it could be a reporting Tableau, or it could be a number of things. But that second level asset now has value to other potential stakeholders. So that becomes part of my data product or potentially a new data product. And then that in its own right is published in the data dictionary, and people are able to access that now as a data asset, as a product. Now, what just happened there is a little piece of magic, because back in the day when we did the data warehouse, we did the same thing. We had raw data and then we converted it into data products, but it was IT doing all the conversion. It was highly complex and it would take a long time to do. What we've done just here is we've outsourced that reasoning and that curation and that building the schema effectively. We've outsourced that second level schema to the business, who had a question to answer and therefore built the schema. And so instead of having this bottleneck, we've now pushed that process out to the business user. So at the end of it, you're probably going to end up with data marts and data sets that might look a lot like what you might have had out of a data warehouse. But instead of waiting 3 years to get it, we had access to it from day one and we built it up over time. And as we were building it, we were getting more value from it, and we were learning more about it. We were providing value to the business. We had people building on top of what we'd already built. So then you got potentially third level and fourth level data assets, which need to go through a process of curation, peer review, and then publication as a data set or as a data product. But that growth pattern happened dynamically, and it happened with business resources coming and helping it to grow. So that's how we grow data products. I mean, it's almost simple in a way, but you've got to have those controls. You've got to have that governance over it. And then the other thing that's represented in this slide is that the data lake supports a multiplicity of tools. So you can come at that data lake for the purpose that you need to fulfill as that person who wants to get their business question answered, and say, look, this is a machine learning question. I'm going to use DataRobot to bring some data in and build a predictive model and then serve it up as an API endpoint, so that when somebody applies for a loan, there's a query to the predictive model that says, on the basis of these 17 questions I've answered, what is the probability that this loan is going to default based on income, marital status, mortgage, all kinds of things like that. And then, in real time, that API sends back and says, we approve the credit card or we don't approve the credit card, built on this data that came from a whole entire history and a machine learning model that was built as a data product, in this case, in SageMaker or DataRobot. The data product could be another relational database, as in like a star schema. It could be a query or a view or a materialized view that has taken 3 or 4 data sets and curated them into a single view of customer, or a very early single view of customer built off 2 or 3 data sources that can then evolve into a more and more complex single view of customer that evolves over time into maybe a customer 360, even if you're bringing in all the customer systems that we can provide. But again, the key point is time to value. Instead of building the customer 360, which could take 18 months, and then serving it up, we build the customer 360 progressively over time as we bring in more and more data sources, and we have more and more people investing time and expertise and subject matter expertise in building out that customer 360. So the point here, I guess, on this slide is that you need to have the ability to support multiple products. And then the way people are accessing those data products might also be through a multiplicity of tools. So you'd have people coming at a schema through Tableau or through Click. You may have that API endpoint that I mentioned with a model that was built in DataRobot. You may have people actually extracting data into Excel and then building something in there. At that point, obviously, they lose the audit trail and you gain all those potential risks around data living in Excel, but it's still a valid use case, and there are still people who are going to be doing that. So it's probably something that you want to support. You can have a dashboard built in QuickSight or Tableau, and it's almost like, I won't say BYO tool, because the tools that the business are using obviously will be approved by IT and whatever, blah, 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 subject to enterprise licensing and all that cool stuff. But we've kind of empowered the business to do a whole lot more with a whole lot more variety of tools. And so that, I think, is probably the conversation. That's how we build our data products. final little thing in here is this AWS lake formation. So that's like a curation layer, and you probably do need to have this from a data governance perspective. Here's the data lake over here, lots of cool data in it. Here's my data products over here and my consumers of the data products. But there needs to be that security layer that says, this is PII. It can't be allowed to be provided except under these circumstances to these people. This is open source data. It's got minimal sensitivity, so provided to everyone for anything. That layer needs to live there. We're not throwing out data governance or any of those disciplines. We're just sort of crowdsourcing or syndicating as much of that functionality as we can. There may still be data sets that are highly sensitive, and they would be curated by a team probably within IT, who are managing those data sets very tightly, the crown jewels, so to speak. But for a majority of use cases, the data products can be initiated, owned, managed, and evolved through those business subject matter experts. And it becomes part of their role. It may be a few hours a week where they curate the data set because they've got people asking them for access to their data product. As long as that's recognized within their job description and is regarded as potentially a little bit of a promotion in their role, because they're now taking on a role of not just a data steward, but a data product owner. I mean, product owner is like the cool term now, right? If you're a product owner, depending on how big and complex your product is, you can just walk in the door and name your price almost, But a data product owner, that's the new data scientist. Data scientist was supposed to be the sexiest job of the 21st century. Well, I think it's data product owner, especially if you've got some data science in the back end of your data product. I have spoken a lot. I'll probably just pause there and let us chew the fat on that. Thanks everyone for sticking around.
I think my question, is similar to what Peter asked earlier. I remember some of the consulting gig that I had in the past, and it pretty much took me on average 3 to 6 months just to get the permission to access certain data set. You can imagine how frustrating it could be. My question then is, given that is the experience that I know that everyone has got, how are you shifting the mindset of the data owner, especially with what you're suggesting in terms of building up all of these data product and data lake, and bringing down that wall of the guardian of the data?
Yeah, definitely. So in a mature organization or in a large complex organization that's regulated, like a bank, in Australia, there are guidelines that apply to them, like CPG 235. And what they say is that your data risk management approach needs to reflect your enterprise risk management approach. And so the data owner would end up, you probably got two layers there, right? You've got the product owner who is at the coalface approving access, etc. And then above that, you've got an executive level who's signing off every quarter to say that we have met our data security, data risk management obligations according to CPG 235, CPS 234, and some of those other standards that apply. So that level of governance doesn't go away. What I'm thinking about in terms of your process is a new person comes along, seeks access to data set. Data catalog has a list of all the data sets that are available. They can actually request access to that data through the data catalog by filling out, this is who I am, this is what I want the data for, and can you provide access? Yes or no, blah, blah, blah. There might be a little bit of toing and froing, but hopefully the process of getting access to that data is a little bit faster and a little bit more elegant. Then the data access is curated through that data catalog. So I get access to an endpoint, either a JDBC endpoint or an API endpoint that allows me to start, in your case, it would have been, I'm going to extract the data and I'm going to put it in my own tool and I'm going to do some cool analysis on it because you're being paid as an external consultant. Or you may be using the on-site version of Tableau or some other tool. But that's how I would see that going. And then if that data product owner had any concerns around the risk, they would go for, through the standard approval process. The data risk owner, and maybe in IT as well, to say, and InfoSec, there'd be a few boxes that would need to be ticked as part of that access process, but hopefully they can be ticked in a matter of days rather than months. possibly even hours.
I would hope so. So the other question I have is, you talk about crowdsourcing the business team or the people in the various part of the business to share in terms of what they know and how they will be using the data, so that that knowledge can be used to build the data product. How successful has that been? I can see where the idea is coming from, and I can see the reason behind it, because sometimes the data are behaving differently or strangely because of some of the business or the system itself behave in certain way. And that is the bit where often the IT team is lacking out, because they don't necessarily use the system or do the business process daily as those business people. But the question is, is there any particular case or organization has done it really well using that example that is publicly available in terms of the information as a case study?
Yeah, definitely. There's a few, and I actually pulled some of them out. I should have left. The BMW is a big one, but let me throw this one. So JP Morgan Chase adopted this model at a huge scale, and they've got obviously a very disciplined IT team in the middle of that, but the products that they're rolling out to the end users are happening on quite a rapid cadence, and they're just making sure that they've got enough data stewards and enough people managing that all of the processes involved in rolling that out. There was a slide in here for BMW that I might see if I can find it, because it had some numbers in it around like 80,000 data product owners, and some of the data now out of their data lake, they're calling it something data cloud. They're exposing that for public access. So for researchers want to access data on where vehicles are driving that these guys are collecting, BMW are collecting in their data lake. They open source that. You can run some analytics on it. Pretty amazing stuff. But it's all come through this process of understanding the data producers or the data owners, product owners, and then understanding the consumers who can come in and do that. So it's definitely been done at large scale. And then one of them, also an interesting case study, is actually Amazon.com. So we get to drink our own champagne, as they say. In fact, some of the learnings came from this. Amazon.com. You've got sellers, you've got a multiplicity of sellers, as well as Amazon themselves, who are a seller. You've got consumers, you've got customer data, you've got this massive, 35 petabyte data lake of all the transactions that are happening on the Amazon.com website. And then you've got interested parties who want to be able to consume that. So in some cases, very large customers who are reselling, they get their own dashboards and analytics and so on. There would be product owners within Amazon who are managing what a customer should be able to see and making sure that, I don't get to see any of my competitors' data, but I may get to see the industry average. If I'm selling sneakers, for example, how do my sneakers compare to sales of all the other sneakers, anonymized by who's selling them? So yeah, a lot of these learnings have actually come out of either what Amazon.com have done or what we've seen customers do. And we kind of keep one step ahead, one step behind the curve, and then what we learn from our customers doing, we teach other customers, and then we learn from them, and it becomes a kind of a virtuous cycle. But yeah, there are definitely companies who have done it at scale, and the exact conversation I'm having with you, I had with a financial services company a week ago, which is where these slides came from. So they're looking at doing the same thing as well. So it'd be interesting to see how that turns out.
Wonderful. Hello. If you enjoy this conversation, hit that subscribe button so we can meet again. If you don't, I'll be stuck in an infinite loop. So pull that part by clicking the subscribe and help me out. You can further support us by leaving us a kind review from wherever you are listening. At the end of the year, I will choose a reviewer to send a special gift to, and it might just be you. I look forward to seeing you here next week for a new adventure. If I can find my way out of this endless loop. See ya.